Are we on live? Hello, take a look. Look. I am actually live. Take a look. Ixo, let's go. Come take a look. Oh, I need to open Twitch too, guys. Sorry for this kind of bullshit each stream. Hello, yo, hello. Where is it? Each stream, I can't do it. Stream, bro. Come on, come on. Come on. Okay, there's my chat. Pop out the chat. Yes. Okay. Can now do this and take this here and this here. Should work. I suppose. Does everyone see what? Everyone see what I see right now? See, yes, that is the case actually. Today, we are on the, how do you call it, on the last section of the, hello there, of the last section of the getting started chapter. So we are going to learn about the camera. Okay, let me make it in the center. We are going to learn about the camera thingies. What do you call it? Camera. How to define a camera, how to move the camera. Like this, you can see we're going to walk around by changing the camera position, and we're going to do process some inputs for that, like the W key, like the S key, like the A key, like the D key. Like this is pretty straightforward stuff if you think about it, because like you know, it's a camera. You just change the camera position whenever you move, and you just set the movement keys to WASD, ASD. Right. Afterwards, it uses a camera class to encapsulate the camera logic in a class. So each any new method, any new functionality can implement it. I actually want to implement it as a camera from start. I want to do it from start. Okay, let's do it then. So let's think about it. What does a camera have? Let's read first until this position, until walk around and think about what a camera needs to exist. In the previous chapter, we discussed the view metrics and how we can use view metrics to move around the scene. We moved backwards a little, yes, because we transformed our model. But we can try to simulate one by moving all objects in the scene in the reverse direction, giving the illusion that we are moving, because if everything else moves, it feels like you are moving. And if you stand, it feels like you are moving, right? Camera. We will discuss a fly style camera that allows you to freely move around in a 3D scene. We'll also discuss keyboard and mouse input and finish with a custom camera class, camera view space. When we're talking about camera / view space, we're talking about all the vertex coordinates as seen from the camera's perspective. as the origin of the scene. The view matrix transforms all the world coordinates into view coordinates that are relative to the camera's position and direction. To define a camera, we need its position in world space, the direction it's looking at, a vector pointing to the right, and a vector pointing upwards from the camera. So we have one vector here, one vector here, and one vector here, so 3 vectors. Yes, a coordinate system with 3 perpendicular unit axes with the camera's position as the origin. Okay. Getting the camera position is easy. The camera position is a vector in world space that points to the camera's position. We set the camera at the same position we have set the camera in the previous chapter. Okay, we are going to definitely need a camera position. Don't forget that the positive Z axis is going through your screen towards you, because like negative Z axis goes into the what do you call it, into the display. So if you want to move backwards, you want to move along the positive axis, like it says. The camera direction, I don't want to watch in it. The camera direction, it's a vector, it's a direction vector. It's a tree, what do you call it? Tree, vector tree, the vector with 3 elements. Yes. Subtracting camera position from the scene's origin vector thus results in the direction we want. For the view matrix coordinate system, we want its z-axis to be positive, and because by convention the camera points towards the negative z-axis, we want to negate the direction vector. If we switch the subtraction all around, we now get a vector pointing towards the camera's positive axis. So we have 3 here, we have -3 here. So it positions, it targets the origin because we set as the 0, 0, 0, and the direction is created from the position minus target. So we definitely need a direction, we need position, we need direction, and the third one is the right axis, the third vector we need. And this is a vector with 3 components again, that represents the positive x-axis of the camera space. To get the right vector, we use a little trick by first specifying an up vector that points upwards in the world space, though. This is important. So we just define 0, 1, 0. Then we do a cross product, because remember, if we use the cross product, we get, we put in 2 vectors, which stand orthogonal to each other, and we get another third vector which is orthogonal to these 2 vectors we've provided. It's perpendicular to the both vectors. We will get a vector that points in the positive x-axis direction. But how? Okay. So the camera direction. Okay, so the camera direction is like this, is like in the minus z and into display, and we want to create upwards, a vector upwards, because we want to find the right vector, a vector pointing right. So the vector is like this, camera direction vector is like this, and we put a vector here that's up like this, and simply calculate the cross product of these 2 vectors. And what we have here in the end is a vector that comes here as the camera right, which starts from the camera position and shows the right direction in the positive x-axis. And the up axis. Now we have the camera direction and the, what do you call it, the right vector, and now we can create the up camera up axis. Starting from the camera, we have a direction vector which starts from the camera, and we have a right vector which starts from the camera, and they stand perpendicular to each other, and whenever we calculate the cross product of these two vectors, we get a vector that is also perpendicular to these two, which shows upwards in the positive y direction. So we have used two cross products, and we have created some how do you call it, some vectors, and then we have achieved what we wanted. And let's see what look at is. So we need 4 components in a camera class. Let's see what the look at is, and I'm going to create a class called camera afterwards. A great thing about matrices is that if you define a coordinate space using 3 perpendicular axes, you can create a matrix with those 3 axes plus a translation vector, and you can transform any vector to that coordinate space by multiplying it with these matrix. This is exactly what the look at matrix does, and now that we have 3 perpendicular axes and a position vector, this is R, U, D, okay. We can create our own look at okay. So the look at this look at matrix. So the look at transforms a point, a vector, to another coordinate space, I would say. Or am I wrong? Let's see. Where is it? Okay. You can create a matrix with those 3 axes plus the translation vector, and you can transform any vector to that coordinate space. So any position we have in the what do you call it, in the program, in the world space, we can simply multiply it with the lookat matrix to make it in front of the camera, so to show it in front of the cameras, to like, you know what I'm saying. Not that the rotation left matrix and translation right matrix parts are inverted, transposed, and negated. Okay, since you want to rotate and translate the world in the opposite direction of where we want to camera will move, using this lookat matrix as our view matrix effectively transforms all the world coordinates to the view space we just defined. Okay, the lookat matrix then does exactly what it says. It creates a view matrix that looks at a given target. So therefore we need 3 vectors which are position, target, and up. So the look at function of GLM calculates all these cross products, I would say, because we simply defined the camera position, the target, camera target, and an up vector, simple up vector. Look at function requires a position, target, and okay. This example creates a view matrix that is the same as the one we created in the previous chapter. Did we create a camera in the previous chapter? I don't think so. I really don't think so. Or maybe I missed it. I might have missed it. Okay, I don't care. Let's keep going. So, what do we have here? Okay. Yes, the view is set to the look at function. So, the view is a matrix. So I will open a cheat sheet here. Cheat sheet. Coordinate systems. OpenGL, I would say. images. I need something like this actually. What is this? Does it say? Oh, this is a lot of information we don't need right now. I mean, I just need to. I just need something like this, the model white matrix, view matrix, projection matrix. And let's just have this here. How do you open it? In tab. This is and whatever. Let's keep it here. So the view matrix transforms world coordinates into camera coordinates. So we have to set the view matrix to the look at matrix because it transforms any world coordinate to the in front of the camera. For delving into user inputs, let's get a little funky by first rotating camera around our scene. We keep the target of the scene at 0, 0, 0. We use a little bit of trigonometry to create an x and z coordinate. Each frame that represents a point on a circle, and we'll use these for our camera position by recalculating the x and y coordinate over time. Y or z, it's set. We are traversing all the points in a circle, and thus the camera rotates around the scene. We enlarge this circle by a predefined radius and create a new view matrix each frame using Okay, let's not get funky for a little bit and create what do you call it, a camera class first. Therefore, I need to open my libraries and include a folder. Let me go. Include util shader.h and just create a new file that is called text document. That please don't do it txt. Did it txt? Let's call it camera.hpp. Did it txt? Hate this. Properties. Change it. Oh, why is it txt though? Did I text document new file? I need a new file. Can't create it. Let's just open let's just open in Visual Studio the folder. Afterwards we create a new file which is called camera.hpp and we define our header. We need the GLM functions, we need the glad functions, and we define pragma variants. We can copy those. We want to include GLM. No? Slash GLM. GLM dot. Where is GLM actually? Let me see. Yes, I need these two, please. GLM slash GLM slash GLM. Where are those? GLM HPP. Where is my HPP? Not here. It's here. Okay, include these two. Fine. The shader isn't it? But the camera, it's camera. Camera HPP. find camera HPP. So here just and the if create our functions. So we need, oh, not this. We need, what did I say? What did I determine? We need a position. This is a vector tree. We need a vector tree target, a direction, and we need an axis. We need the right axis. We don't need those three. We don't need these. We simply need up, which is this, and the target. So the camera target is, let me define it, class camera. Camera. Okay, the private methods are vec3 using namespace glm, of course, glm vec3 camera target and camera direction, yes, these are the need an up axis. This is predefined, so I will simply define it. Camera up. This is simply up. I will predefine it by calling it 0, 1, 0. Yes, and I'm missing something. I don't think so. I need methods, of course. I need a matrix. I need view matrix. This should be public though, so public, or I make it private too, because I will simply use transform. Transform, I don't know. Let's call transform. View. How do we create view? It's a mat4 view, and view is created by simply calling look at with the camera target. Camera, not target. This is unnecessary. Camera origin. Camera origin and camera target and up. So this is how it is created, and yes, as a public method, we can, as a public thingy, we can simply define a transform method which gets a vector as a parameter and overrides this vector. It simply changes it. It's a void method which we are going to call transform into, maybe, or do we want to do it actually? Because in the fragment shader, you would like, in the vertex shader, you would like to define this, define these matrices as an MVP matrix. So you don't want to transform them before vertex shader. Yes, so I will simply return my view matrix here, mat4 get view, which returns the view. Let's make it const. course. This actually. Yes, it returns the view matrix. And do we need anything else, you would say? I don't think we need. We could of course set the camera target and camera origin. What do you call it? Set camera target, set camera target with another vector, of course, vec3 value, and this will then simply say that camera origin equals to value now. And afterwards we can also set an origin and target same as before. It's another vector called value, simply sets it to the origin. So I don't know in C++ if it's better to define these as private and then simply afterwards call them with various public methods. I've learned it in the Java so yeah, you need to close anything you can and only let people modify using your setter method. So actually I think we are ready. I can implement methods here to change camera origin or camera target. I think I will do it actually. I will simply say that process input and call it glf w window and it's of course a void method, and I will simply say I will also define a constant float camera speed here. Yes, and I will also say set camera speed with a value, camera speed then should be equal to this value. So this process input method should simply get 4 inputs, which are switch, switch G. You don't do it actually though. It's not. How bit though? A bit. This is a bit. I don't know how. How do you? I don't like this. I will open Chat GPT and ask if this is the only way to do this, because I want to use a switch case. Is this the only way to check between to create a control sequence between characters in OpenGL? I like to use a switch statement instead. Oops, I didn't provide. Here it is. Bro, I don't need this shit. I just need to um oh, of course, I mean like ah, okay. This is a good insight actually. You can get the key and you can this code system does the same thing as your original code, but uses a switch statement to handle different. So you have a method called glfw get key with the one parameter. Returns the state of the key being pressed and it's switch based on the key value. Okay, this is nice. This is nice. So you simply say glfw. Of course, we say key first. glfw get key. Oh, we don't include glfw. Oh, thanks. You always help. Childish dev, please. Main CPP, please. glfw. A little bit. glfw here. Okay, switch. Like this. Please say something. Please. It doesn't fill the code. Why? Jet key. Window, of course. And switch it. Switch key. If it's case. What do you call it? Bro, I need these. Can't I rename it, please? Code suggestions. Okay. Shouldn't work like this. LFW key V. W, I mean. It should simply. Okay, I will define the cases first. Okay, case FW key A case FW key. W does this. It changes. It changes camera origin. Set camera origin to a value. Course, I value this camera origin error type plus uh, uh, I don't understand why do we get error type here. Do we need to do this? I don't think so. Doesn't look good. Doesn't look good really. These things are not even highlighted. But why though? Can't it see the GLM? I think it can see. Can you see this? How can you see this though? What is going on? This is standard IO. Therefore you can. But how? Oh, where do you use GLAD here? GL shader source here. It is. Okay, so it functions, but I don't know. It doesn't code. They call it code recommendations. Okay, let's say this is dot camera origin plus. Where do we want to move it? We want to move it and the positive direction, which is minus z, which is front, and 0 0 1 1 is camera origin plus this front times this camera speed. So set camera origin, this camera origin plus times, okay. So the W does this, the S does this, A does this, D does this, and another, it shouldn't exist another case. Default is an error. We don't do errors. We don't default either. This is minus, it moves to back, but how does it work with A? It should go minus right, no? A or minus right. This right, camera right, no? Right? There isn't. So I didn't define camera right. So the camera right, vec3 camera right is equals to camera target time, I don't know, just cross here, right is up, and camera direction, we don't have camera direction either. So we have up, we have target, and we have origin. So origin and target define the direction. So I can write GLM, I don't need GLM, I need cross, and here is camera direction, which is defined by camera origin minus camera target, and on the right side we have camera direction, camera right. Okay, so we have cross up and camera direction. So we have here this one up and camera origin minus camera target, and this is normalized. Normalize this cross. Should be ready now. So, okay, and we have our camera right. So this camera right minus what times, and this is also plus if you want to go D. Camera right. Oh, this should be it. Yeah. Yes. Up X. Okay, we don't need this. We don't need this. Walk around. Look at put movement speed, delta time. I will actually try it afterwards. I want to create my camera first in my code, so I will simply change to my main code and include where's hashtag, include my util camera header. and I should define the shader camera in the loop. And here actually, no, here we create the camera here. Okay, so the view. So we have here a camera right now. Camera which is created by lots of things. Oh, I forgot the constructor. Created the constructor here. Oh, constructor is this. Okay. Okay, I should set the constructor. Constructor camera in the public. Where are you? Public here. Guys, go down. You're here. Camera, which is created by two things, three things, I might say. But I will make a camera default camera speed and change it afterwards if I want. So I will say two things: vec3 camera origin and vec3 camera target. I need these two, and I will simply set camera target equals camera target and camera origin equals camera origin. Of course, I think I need to go this. I think no. And it should actually
Brian Garnet the King dropped his crown.
Hello. Should do it. So if I change to my main code here, and if I what's this? My okay, camera here, and if I say like the guy here, I will simply say this. That's the up vector here. What do you need, my guy? What's the up vector here? The target is this, that's for sure. So the target was the second one, no? Yes. The origin is 0. No. The origin is in the positive direction. So we set vec3 and 0, 0, 3. And here we set vec3 0, 0, 0. What is this? Bro. What do you mean? It is exactly the same. Let's see. Okay, my problem is actually here, I think. Header file does not find or see another header file. OpenGL, actually. I don't need it. Including OpenGL header file, but I can't use. I am actually importing the GLAD. Does my think the you can't find it, no? Can it be? It's I'm written okay, V right click here and we click properties. Yeah, shit. Okay. Nice. Nice. Let's see. Let's say dot glad. Maybe it sees then. Dot glf dot glm. Yes, we did it. Okay, I got what the problem is. The problem was that we defined in this solution, we defined the what do you call it? We defined the uh, libraries here in the dependency page. I don't know, what do you call it? Yes, but we didn't do it in our second util file. So I need to make the util file really find the header files. This should then okay now. Okay. Do you say camera? Create camera then. Hashtag include util camera age. Maybe it reloads. Back 3. Please. It 0. The target 000. And this is weird actually. Just created it, no? This is a public method, uses true vectors. I see how it doesn't work. And what happens if we, for example, set the camera and we can't do anything with it? Why? What is this? I want to do stuff with it, no? It sees my... Okay. F. What do you mean? This works? This is so weird. Expected a type specifier. I'm giving you the types. I can understand this. This is simply a float. Understand? It's simply a float. This is so weird actually. Let's say it's an up vector, and up vector equals to a vectory F0. This header shit is bullshit. It's not safe. Alright. Okay, shader does work. Really work actually. Let's say let's create util files here from now on. Open the solution. Terminal. 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 I don't know. Window maybe. Oh, I can't find the terminal. It's ID. Okay. Childish dev thingy. Folder, please. It is called. Oh, it is called util. And I will need the shader util folder and my camera too. These three come here. Control C and paste the file. Okay. Now to have this, please reload it. Reload it. Sync. Synchronize it, please. Where are my files? Okay. This. What is this? What is this? Okay. I think I can find it. Add. Model. I don't need a module. Add. Okay. This might be it. Stuck. Delete this. What is this? This name reader camera. Okay. Camera. Dish. Okay. But can I simply put this here? This it. Okay. Include camera. Can't include shade camera. Think. I don't need to delete it. Fine. Okay. Still can't find anything. Solution Explorer. Delete. Delete this. Oops. Sorry. Sorry. Delete this. Delete. Okay. What time is it? It's 17:40. 20 minutes. 20 minutes more to do something. I need to open this. Open it. Sea lion, please. Yes. Just once. I am trusting the project and how the sea lion works for us. Project config CMake project. Not a CMake project. Exit this. I will try to open it with Sea Lion, the lead project. This is in childish dev. This is solution here. Repos childish dev. Want to open this with? Can't open this with Sea Lion. Fuck. Yes. You make it here. Extracted for just doomed. I need to see the guy's code in GitHub, preferably. GitHub preferably includes learn OpenGL shader. And this is okay. Yes. So guys, I need to make a cut here because I'm not coming forward. I will look what am I doing wrong and try to fix it off stream and stream again in the near future. Have a nice one. See you later, alligators.